some of the problems around variant modeling at a high level, necessarily so in what we've got now, 40 minutes. And then we'll look at a solution. And again, I'm going to give you a sort of high level overview of the solution that we at Scarecrow have got. And then we'll hopefully we'll have some time for some questions at the end. So, many of you will be familiar with our 3 packages diagram, or in this case, our 3+2 packages. We also call it our MBSE in a slide diagram. And this is a useful diagram to sort of set into context where variant modeling comes in. Variant modeling comes in very much on the approach. Yes, you use it when you are creating your model of your system, so it's used here. But the key thing is that however you're going to do variant modeling as part of your MBSE activities, you have to have it defined over here. So it has to be a defined part of your approach. And you won't be surprised when we come to our solution that the way we do it, uses our usual framework ontology viewpoint approach to doing variant modeling. And then, of course, you have to think about implementing it in some particular tool. So I've got people. So you implement it over here. And like I say, as with everything MBSE, if you're doing it properly, it's not just a case of throwing it into the middle bit, into the creating your system. You have to have a defined approach in place, and it's no different for variant model. And you have to implement it in the tool. Now, in terms of where variant modeling sort of fits in on your, we call it our evolutionary path, our evolution from document-based to full model-based systems engineering. In terms of where it comes in, it's really very much at the late stages, going right up to the final stage 5. I'll come back to that in a couple of slides' time, but it sits very much on that right-hand edge of our evolutionary scale. So, the first thing to that you have to wrestle with if you're going to be doing variant modeling as part of your model-based systems engineering activities is which approach to use. We are unfortunately not in the situation where we've got a massively sort of common approach that's out there. There are lots of approaches. Some of them listed here. There's a thing called feature-oriented and domain analysis, but that's quite old. That's crikey, 30 years old now. Crikey, were the 90s that far away? We've got something called common variability language. That was something that the OMG, the Object Management Group, were working on, and they were hoping to publish it as an OMG standard in the same way that they publish UML and SysML as an OMG standard. But that's sort of fallen by the wayside. A common one that is implemented in some SysML tools, I certainly know that what was Artisan Studio and then became a Tego modeler, and I think it's now called PTC Integrity Modeler. They were certainly playing around with something called orthogonal variability model, the OVM, which I think came from the University of the Ruhr in Germany. Tim Valkins, who's a very well-known author on SysML and MBSE, he has an approach that he calls VAMOS, the variant modeling method for SysML. And they are talking about including aspects of variant modeling in SysML 2.0, which is sort of still under development. So the first problem you've got is which approach do you use? The second problem that you hit is, or the second sort of types of problems is around how you actually use one of the approaches. The first issue is, and a very, very common one, is duplication of effort. In a lot of the methods, you almost end up modeling your system twice. You model your system using, you know, normal SysML or your own framework, however you want to do it. And then you model the variants, and then you map your variant model to the system model. That's certainly what OVM does, for example. So that's an issue. You're essentially, you know, defining things twice in two different kind of languages, if you will. The second really common issue is the notations sort of non-standard. You know, if you've got people that are all trained, you know, in UML or SysML, and then you pick one of these methods like FODA or OVM, they then introduce their own symbols and their own notation. So there's a whole other sort of notation that people have got to grapple with, rather than using sort of standard SysML notation. And then the third problem is they're not all that clear in their definition. And by we I mean Scarecrow, we had a good look at Tim's Vamos. It's published as an ebook, and we struggled to understand some parts of it and how it was meant to work. And then, of course, you know, you can pick a method, but it may not be supported by your tool of choice, which may mean that you've then got to implement it yourself, or you end up then picking a different method. So they're all common problems that we see when we try and do variant modeling. The third thing to talk about, so not only which approach do you pick in the first place, not only all the common problems around you know, implementation and duplication of effort, but the third problem is that variant modeling is absolutely non-trivial. People that have been on these courses since the start know that we've sort of touched on this a few weeks ago in one of John's presentations. It really is non-trivial. If you're doing this sort of from scratch in a SysML tool, it can be very difficult, particularly if you're trying to sort of bake it in yourself. We tried to do it and failed twice. In both cases, we tried to adopt existing approaches to variant modeling, and we tried to adopt those to the way that we work in Scarecrow and the way that we use our sort of framework, you know, based approach with an ontology and defined viewpoints. And we failed both times. It was so much effort, and it meant we had to do things in such a different way. It was an absolutely pure example of the tool leading the process and not the other way around. And of really sort of major importance is to remember that because it is non-trivial in terms of some of the concepts and what you're trying to do with variant modeling, is that in terms of our, you know, MBSE evolutionary scale, it's way over, as I said right at the beginning, it's way over on the right hand side. You know, you've got to be able to walk and jog before you can run, and variant modeling is running, and it, you know, it's sprinting. It's definitely at that end. It's not down here. And again, John will have talked about this on some of the other presentations that we've done. We've engaged with clients who are down at stage 1 or stage 1.5, and get us in to help them do their MBSE, and at that point say, oh, and you know, can we do variant modeling? And in one case, at 5:15, when I was due to be leaving the premises at 5:30, they said, oh, can we spend the last 15 minutes adding variant modeling into our framework, please? At which point, you know, polite refusal was the only option. So variant modeling, if you're going to do it as part of your MBSE approach, it's no good doing it if you're down here on your life, on your evolutionary sort of path. You've got to be doing it up at the top end, up at the right hand edge, when you really are familiar with the use of frameworks and tailoring tools and all those kind of things. Okay. So we've talked about some of the problems. There's different approaches out there. Not all tools support those approaches. Some of the approaches mean that you end up duplicating effort, and it's a very much, you know, high-end kind of concept in terms of MBSE. Let's look at the way we do it in Scarecrow now, our approach. So we're going to look at a solution. We don't call this the solution, you know, it's a solution. It's a solution that we created that works for the kinds of projects we've been working on with customers. It's a starting point. You know, it can be changed, it can be adapted. It's a starting point, you know, maybe for tailored solutions within other organisations. And when we set out to come up with our approach, this is after we'd failed twice by trying to use existing approaches. We stepped back and we did what we should have done right at the beginning, and we said, what are our requirements? And essentially, these are the four sort of headline requirements that governed the way that we finally managed to approach it in a successful way. The first thing was, it absolutely had to use, you know, the existing sort of modeling language that we use, which was SysML. We didn't want to invent something or to use something that used a non-standard notation. We wanted it to be SysML based, and it had to fit in with our standard ontology and framework and viewpoint kind of way that we work. And certainly, I know there's at least 3 or 4 people on the call today that are familiar with that and that we've done work with or trained in that approach. The third requirement was you know, a really important one as well, and this was this problem with duplication of effort that you sometimes see in some approaches. We wanted whatever solution we came up with to be one that we could add to an existing system model. We didn't want to have to model all the variation stuff sort of completely separately and then join the things up. Yes, there are concepts and views that you have to create purely for the variant modeling, but a lot of the aspects of it you overlay onto your existing model. And the fourth requirement was that we wanted an approach that would support some level of automation, both in terms of conformance to the approach. So, you know, using things like scripting within tools to make sure that our variant modeling in a particular system that we were modeling actually conform to the variant modeling approach that we defined, and also automation about extracting the variant. One thing we wanted to be able to do was, once you'd marked up a model with variants, to actually be able to pull out particular variants that you defined as a new model that you could then work on. So you could create, you know, 2 or 3 different variants of a system and pull each of those 2 or 3 variants out as separate models, which you could then develop outside of the sort of the overarching variant model. And I've put semi automatically there because the ultimate aim is to do it completely automatically, but there are tool limitations around some of the issues, particularly in the tool that we were using. There were some things that in theory should be able to be automated, but the API on the tool wouldn't allow us to do that. So we had a bit of manual intervention, but it probably did sort of 95% of the work for us. So based on those requirements, we came up with our approach, and there are a number of um, assumptions, if you like, that our approach makes if you're going to use it. And the first thing is that you have a model of your system. Obviously, you can't do variant modeling without having a model of your system. So you've got to have a model of your system. And our approach also assumes that you are using a framework-based approach to modeling, where you've defined your concepts, your ontology, your names for things, system, subsystem, part, assembly, operation, whatever language you use, and that you're using that kind of viewpoint-based approach that goes along with having an ontology in place. And the other assumption is that you're going to then annotate effectively your model with this extra sort of layer of information, this variant modeling information. So what I'm going to do now is I'm going to go through on a number of slides the key concepts. I'm going to skip the next couple of slides, which are the sort of textual descriptions of some of the points I'm going to talk about. They'll be there, when if you download them, so you can read them a little bit more at your leisure. But I'm going to go through the slides and make some points about some of them. So it's a model-based approach. It uses our common framework ontology viewpoint technique. It assumes that the model that you're going to put the variant modeling on has been created using that kind of approach as well. And there are a number of key concepts. The first one is variation point. And variation points are about saying what concepts are allowed to vary. And this is why we say you have to have your ontology defined, because this one actually relates to the ontology. So the stuff over on the left-hand side of the diagram, this is stuff that's in your ontology that you would have in place, because you've got your MBSE approach defined. And then you create a view that says which of the ontological concepts. Now, here I'm relating to elements, system, subsystem, part. In theory, you could do the same thing and relate to relationships between ontology elements. I've just got quite a sort of structural example there when I'm relating to the elements. So what we say here is system, subsystem, and part. They are things which I am allowed to have variants of. Things that are identified as being systems, subsystems, or parts are allowed to vary. You'll notice that subsystem port and part port, I haven't got variation points. So I'm explicitly now forbidding those things to have variance in my model. And this is one of the things that we did for the checking, because we can now have scripts that make sure that only things that have got ontology variation points associated with them have variance later on in the model. We automatically check that we haven't tried to vary system subsystem ports or part ports, because we're explicitly saying that's not allowed. And then here we've got an example of an actual sort of view, if you like, from a system. It's a real system. It's a Crofton steam engine on the Kennet Navan Canal, and you'll see here we've got model variation points here and here that have been added on to our steam beam engine and our building, which you can also see have got the system stereotypes as well. So these started off in the model. These are both systems, and we've overlaid this second sort of layer now. We've said these are now model variation points that conform to the ontology variation points. And I can put those on because steam beam engine and building are systems, and we've said systems are allowed to vary through this relationship here. Okay. So there you go. Steam beam engine and building are systems that will vary. We then have the concept of variation elements. So the model variation points now, and here I've moved down a couple of levels onto a subsystem, a boiler and a part, a fuel source, again, just to show that we've got examples of those that are varying. The variation elements then start coming in to tell you what different variations you can actually have of those things that you're going to vary. So the model variation point on here and on here tells me that they will have different different variants available. Okay, and anything with the model variation points are abstract in the sense that they have to have defined variation elements. What we're saying is there's no such thing as a boiler. It has to be a specific sort of variant of that. And that's where the variation elements come in. So this is saying now that for a boiler, we've got two different types of boiler, two different variants, if you like, a coal-fired and a gas-fired, and similarly for fuel source. And we've got annotation, you can have X, or in some cases you might want to have some multiple inheritance or multiple subtypes. Here we're saying a boiler has to be either a coal-fired or a gas-fired. You can't have a combined boiler. And also you can put in relationships between variation elements. So the top one says, you know, if you decided that you're having a coal-fired boiler, then you have to have coal as the fuel source, and similarly, a gas-fired boiler has to have gas as the fuel source. That's what these require. That's what these require relationships dictate. And again, this comes in for automation. This is how we can check in our model that we've not picked incompatible things. We've not said, okay, we're building a system with a coal-fired boiler, but we've picked gas as the fuel, because that requires Link won't allow us to do that, and that's something that can be checked through automation. So the model variation points are the things that are going to vary. The variation elements essentially are the types of variants that we're allowed for them, and they can have, as we see, things like required relationships between them, so that we can govern dependencies. Let's see if I can. Spurious. No. So the next concept that's related to variance is just the fact that, you know, they are model elements in their own right, so they can have structure, just like any other part of your model. The fact that they've got a variation element stereotype on them doesn't preclude you just modeling them normally. So they can have a normal sort of structure defined. So we can see that our single beam, it's made up of a water pump, a beam, a steam cylinder, a condenser, a boiler feed pump. And here now we're saying, okay, we're actually picking the fact that it's going to have a gas-fired boiler. And again, we can put a required through here from the single beam engine, because it's a variation element, to another variation element saying whenever we have a single beam engine, it has to be a gas-fired boiler. It can't be a coal-fired boiler. We can also relate at a sort of abstract level. We can relate our bits of our system to model variation points. So what this is saying is the single beam system, it has to exist in a building. It has a model variation point associated with it of building, but we haven't used a variation element for the building, which would be defining a specific type of building. We've used the abstract model variation point, and this says that we actually don't care what kind of building it goes in. So it absolutely has to be in a building, but we don't care what it is, and that we know we don't care because that's a model variation point and not a variation element. Right? So, in fact, I'm just going to go back a slide. So if we go back to these slides here. So essentially what we're saying, just to recap, is let's start here. Right. First of all, we're saying what concepts can we vary? We can only vary systems, subsystems, and parts. We use model variation points then to annotate our model to say which of those systems, subsystem, and parts are we actually going to vary. We then, for those model variation points, we use variation elements to say, and these are the different, types of different variants of boiler, fuel source, whatever it is, whatever model variation point. That's what we use the variation elements for, and we put dependencies between them to say that particular elements are required. So if you pick one, you have to pick another one. We also have an exclude relationship as well that says if you pick this one, then you might have, I don't know, 5 different fuel sources that a particular kind of boiler can use, but there might be one of them, there might be a 6th one that it can't use. So rather than it requiring one of the 5, you can do it the other way around and say, it can be any fuel source excluding this one. So we have an excludes concept as well. So the variation elements say what different, variants we're going to have, and they can be related together. They can have their own structure, and that structure has to honour those requires links. Where part of my system, has to be in something else that can vary, but we don't care what particular variant it has to be. So in this case, the single beam has to be in a building, but we don't care what kind of building. At this point, we stick with a variation point. So far, the concepts we've covered allow us to identify what can vary and the different variants we've got, and how aspects of those different variants may depend on other aspects. That picking one will force you to pick another one. You pick a vehicle that's got sat nav in it, you have to have the touch screen interface as part of the AV system because it's used by the sat nav. So those kind of sort of concepts. And again, I've talked here purely, this is a structural example, but we've used this where the concepts are operations functions, if you like, where there's variance on the way things are implemented. We've used it where the variations are not on the structure, but are on the relationships between things, whether particular relationships exist or not. So you can use it, for all different sort of aspects. Once you've done all this, you can then actually start to come up with your configurations. And there's sort of 4 aspects that come in now. There's first of all, what configurations are you allowed? What instances of them are you're going to build? You don't necessarily have to do that, but you have to have the variant configurations. And then for the extraction part, you have to then do some work to say which views are touched by these variants. So the configurations bit, this brings in the concept of a variant configuration. And we've actually got 3 here, one of which is abstract. So we've got this variant configuration now, saying we are defining now a single beam system setup here, and that single beam system setup is made up of a single beam engine, which has got all of its structure underneath it with its required. So it has to have a a gas-fired boiler, and that has to use gas as the fuel. We've got those required links in, and that single beam has to be in a building. But we've now got these two specializations of single beam system setup, setup number 1 and setup number 2, and you'll see that the setup number 1, the building that it is requiring is a shed, and the setup number 2, it has to be housed in a museum. So these are sort of two concrete variant configurations that inherit all of this bit through the single beam system setup, but then specialize it through the actual buildings that they are going to be housed in. Okay. Those variant configurations now are that, so essentially that's now defined the two different variants that we're going to build, the two different configurations we're going to build, or that we could build. We could build a single beam engine housed in a shed. We could build a single beam engine housed in a museum. And here I've used the sort of building as the variant. I could quite easily, for example, have had the bit that distinguishes them being different kinds of boiler, for example, by having sort of the gas-fired boiler as the distinguishing features. But here it's the building that I've focused on. We can also show instances of those variant configurations now. So we have variant configuration instances, and what we've got here, so we've got two instances of the single beam system setup number 1. We've got one in Swansea where John's based, and one in Wolverhampton. We haven't really, but you know, conceptually. And we've got one instance of the single beam setup number 2, which is at Crofton, and that is an actual one that exists. So it's possible that you can actually create these instances. This is probably of less use where you are mass producing things. So, you know, something like automotive where you're making, you know, thousands or hundreds of thousands of a particular variant configuration. But for some systems where the number of instances that are created, you know, are relatively small, then this can be quite useful. On those sites themselves, you know, they're only blocks essentially in SysML. So those variant configuration instances as well could have, you know, further details on them. So you have to have you have to define the variant configurations. You don't necessarily have to have any instances. And then the final concepts are around what we call viewpoint sets. We know that the concept of a system is going to vary because we've created an ontology variation point for it. So anything that has an ontology variation point associated with it must have what we call a viewpoint set associated with it. And we know from our framework, because don't forget our approach depends on you having a framework-based approach in place. We know from our framework, for example, that system can appear on a number of different viewpoints, which are identified here. So we know that system can appear on those viewpoints from our architectural framework. So those viewpoints have to appear as part of our viewpoint set. And again, that creation of the viewpoint sets, essentially we automate it in our tool, because as soon as we create the variation point and put that link in, we can look in our definition of our framework. We can automatically find that system appears on all of these viewpoints, and hence we can create a viewpoint set that contains all of those viewpoints. So we can automate the definition, the creation of the viewpoint set. essentially this diagram is how you create that viewpoint set, and we can essentially automate that diagram in its entirety. As soon as we've put that part in, the rest of that diagram we can automatically generate from information in our model. And then to finish off, those viewpoint sets are then used as part of the functionality to extract information from the model. And this is where users have to do some work themselves. The variation element has a variant associated with it, and the variant is the thing that essentially identifies the bits of your model in terms of the views that you've created that might need exporting out when you are pulling that variation element out of your model. So every variation element has to have an associated variant. So again, as soon as you create the variation element, you can automatically create the variant that configures it. And again, we do that through scripting. That variant then creates the view sets that identify the actual views that are that contain information on that variant in the model, and those view sets have to exist for all of the elements that make up the variation element. So our single beam, if we go back a number of slides, it's got a we can see it on here. It's got a water pump, a beam, a steam cylinder, a condenser, etc. So all of those elements that then, which are here at that level, each of them will have a view set associated with them that specifies the diagrams, if you like, the views in your model that contain the information. And those view sets correspond to the viewpoint sets. They're essentially an instance of a viewpoint set. Now, the references, these things inside the view set, these are references to the actual diagrams now. So the variation element has a variant. That variant contains view sets, and it has a view set for each of the things that make up that variation element. And that each of those view sets have view references, which are references out to actual views within the model now. I've omitted them for the other things, condenser, beam, and whatever, just to keep the diagram tidy. So these view references now actually do point out to another diagram somewhere in your model that's got, in this case, it would be the configuration view for the water pump that shows all the bits that are on it. The reason we do this is that this variant and the view sets and the references, this is how we can then extract information from the model. So if somebody's okay, I want to pull out single beam configuration number 1, it works through the tree, it finds the variation elements, it finds their configured variants, it looks inside the view sets, and it pulls out those views, those actual diagrams, if you like, SysML diagrams ultimately in your model, and everything that's on them, and that's what gets exported. So the addition of the view references into the view sets, that's the one part of the sort of extraction that the engineer has to do, because there may be a whole load of views, you know, that the water pump actually appears on that aren't really of relevance to the you know, to the variation, and you don't really need to export them. So these view references aren't automatically populated. Pretty much again, everything else on here can be automatically created, but the engineer has to then go in and say, okay, my water pump, it actually appears on these diagrams. Is the stuff on there? Are the things on that diagram that I need exporting as part of my variation? If so, put them into the view set. And as I say, it's the things on the view set that are used to export that information. Because the single beam itself, one of its elements is itself a variation element. That's going to have its own variant for the gas-fired boiler, which has got all of the view sets for the gas-fired boiler. So we don't duplicate that information. We use this uses link now, which tells us that the single beam, its variation, its gas-fired boiler is itself a variation element. It's got its own variant. So that's so from the point of view of the single beam, it says essentially my variant doesn't have to include information on the gas-fired boiler. We can go away and use that other variant that already exists. Okay. So, in summary, I'll I know we slightly over, I'm going to go right back and just very, very quickly go through it all, because there's a lot of really deep concepts here. This is why I said variation modeling is hard. We start off with what kind of concepts we want to vary. We want to be able to vary systems, subsystems, and parts, and nothing else in this example. Okay, which systems are we going to vary? We're going to vary the beam engine and the building. Okay, for the things that we are going to vary, what actual types of variant do we have? Okay, for the boiler, we've got coal-fired and gas-fired. For the fuel source, we've got gas and coal, and we can link them together where we've got dependencies. We model our structure. That structure can use other things that are marked as being variant, in this case, the boiler. By the way, there's an implication here, because water pump, beam, steam cylinder, condenser, and boiler feed pump aren't marked as variation elements. They will be the same across every variant that we come up with. Okay, they don't change. In this case, it's only for the single beam engine. It's only the type of boiler that can change. So we define our structure, which can make use of other variation elements. It can make use of variation points where we don't care what kind of variant of building it sits in. It can be in any kind of variant. Then we define the actual configurations of those things that can vary. So yes, we can vary the boiler. Yes, we can vary the building. Yes, we can vary the fuel. These are now the ways that we're actually going to put those together to build our system. We're going to build two versions of the single beam system. We're going to have one in a shed, one in a museum. So in this case, all of the other stuff's the same. It's just the building that's going to be different now. We can show instances of those, where they're located, maybe in time or in space. And then we define the viewpoints that we need to check when we are thinking of exporting our variant out of the model into a new model. We start by defining or identifying the relevant viewpoints, instances of which views are going to have information on that we might need to export. I said that diagram can be completely automated based on that link over here. And then we create these view sets which contain references to actual diagrams, which have got elements on and which exist in my model. And it is these view sets with their view references contained in a variant for a variation element that dictates then what gets exported from the model when we want to pull out a particular variant. So there you go. So in summary, as I think you'll appreciate by the number of concepts I've just thrown at you. Variant modeling is hard. It's hard because you have to think about what things you want to vary, how they can vary, how you can, what are legal combinations of those different variants, and you have to think about how do I identify the necessary information that I need to export from my model when I want to pull out a particular, in our language, a particular variant configuration. It is hard. You have to tackle it at the correct stage of your MBSE evolution. Don't try and do it too early. There are many flavors over there. You do need to choose for yourself. You be aware of duplication, whether you end up having to model things completely separately twice. Beware of non-standard notation and unclear definitions. We have a solution. It's still a work in progress. It uses SysML. It annotates your existing model. Yes, there are additional viewpoints defined. There has to be, but essentially all of the structural stuff is your existing model anyway. You're just adding new stereotypes to it. Our solution isn't tool specific. It's a generic SysML based solution using a framework based approach, and it's designed specifically to support automation. I can see that John Cashmore's got his hand raised. John, if you want to unmute, if you've got a question.
Thanks, Simon. I was just wondering how much of this variant modeling overlaps this 26580. Sorry, I'm reading that off the web. The variant modeling product line engineering approach. Are you tracking that at all?
Not. We haven't been, to be honest. Is the short answer? We haven't been tracking that. We've created a solution that works for us in the SysML tool that we use, that works with the way that we do our modeling. There are lots of PLM tools out there. The problem is that although there are some, very, very good product line tools, most of them don't integrate with your traditional MBSE tools. By that I'm really meaning your SysML tools. So we sort of almost made a conscious decision not to be influenced by some of that stuff, because as we found out to our cost twice, some of the language and some of the approaches just didn't sort of fit in with the way that we work, which is why we say this is a solution. This is our solution. It's not going to work for everybody, but I can say for certainty, because we've done it, if you use Sparks EA, this works very well, and it can be automated. And for a lot of what a lot of people are doing, it's perfectly fine. It's been used successfully on an automotive project with one of our customers. But yeah, we haven't particularly been looking at that standard, John. Any Ian?
Yeah, hi. Actually, I have a very similar question to John's question. It's also about product line engineering and variant management. So from my side, I do find confusion over when people should be thinking about variants and when they should be thinking about product lines. And I just wondered if you've kind of got any kind of patterns or anti-patterns that you've kind of identified for variant management versus product line.
We haven't yet. That would be a very, very interesting area, actually, Ian.
Yeah, because there is a lot of overlap, isn't there? So
there's a massive amount of overlap. Yeah, and in a lot of organisations, the terms are used, interchangeably, pretty much.
Yeah, I would say widely misused. So people don't understand what a variant is, and typically don't understand what a product line is.
Yeah.
But they just kind of bandy the terms around quite a lot of the
Yes.
time.
Yeah. But that's certainly, I mean, that's a nice idea. That's certainly something I think we could start looking out for. Yeah. I mean,
Okay.
I think that'd be good both for the MBSE working group, and I think for the automotive as well, because as you well know, it's a
Yes.
big area in automotive. The customer that at 5:15 said, "Can we now add variant modelling into the framework?" was in automotive.
Yeah, that doesn't surprise me.
Yeah. And as I say, a polite it was. I knew him very well, so it was a slightly less than polite refusal. But that I think that would be quite an interesting thing to look out for, and particularly the anti-patterns kind of stuff as well. The bad sort of patterns to look out for. It'd be very useful.
Okay. Right. Thanks.
Time for one more question, otherwise we'll finish now. No more. Nobody else has got their hands up. Okay. Well, we'll finish there. Thanks, everybody. We've had a really good attendance today. Lots of people, some new faces. Like I say, the video and the slides will be available hopefully by the end of the day, if not by the end of tomorrow. So it's worth checking our YouTube channel out, probably tomorrow, to see if the video's up there, and look on our knowledge base. That'll certainly be done today. Look on our knowledge base to download the annotated presentation. The annotations aren't going to be that useful. It's more me just drawing circles around things anyway, but they may help. I hope you can join us next week. Not sure what the topic will be next week, but we should be doing a session next week. And if you can join us for the social we'll probably be a little bit late starting now. It's 4 minutes to 11, so I'll probably kick off about 11:05. Please come along and join that. And if there are issues that have come up today that you want to talk about in more detail, or explanations you want in more detail, the social often is a good place to do that. It often turns into be a sort of extended sort of question and answer session. So we'll end now. I'll stop the recording now. Thanks everybody for coming. Hope you found it of some interest, and at least got you thinking about things, and hope to see many of you in the next session. Cheers. Bye.